So, the first question of the given worksheet is, I think, exercise 9.2, third question, right? So, what is this third question? The third question is that if two equal chords of a circle, if two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection, the line joining the point of intersection to the center makes equal angles with the chords. So please try to understand this problem. If two equal chords of a circle, okay, so that means let us take one circle, okay, and after that there are two equal chords, it seems. There are two equal chords. So let us say this is AB, and CD, and they are intersecting within the circle. Intersecting means they are meeting somewhere. So let us say this as CD. Okay, they intersect in the circle, within the circle. Prove that the line joining the point of intersection. So is this the point of intersection? So P, the line joining point of intersection to the center. So join the line. Okay, let us say this is center. Makes equal angles with the chords. So if this is the line joining, where is the chord? This is the first chord. What is the angle made by this line and the chord? This one. Okay, and with the chords, so other chord also, what is the other chord? What is the angle made? So you have to prove that OPA is equal to OPD. Understood? See, whenever you read a problem, you have to, the first thing you have to do is try to represent the same statement with the circle. Now understood, everybody? So these are equal chords. Let us write the answer. So given, what is given first? Equal chords. So that means AB is equal to CD. These are equal chords. Okay, and prove that the line joining the point of intersection. So what is the line joining point of intersection and center? OP, makes equal angles to the chords. So that means what to prove? To prove what you are supposed to do? OPA, angle OPA equals angle OPD. See, how will you prove? So we can't prove this directly, right? So we have to use the theorems. What are the theorems we have seen? Equal chords subtend equal angles. So if I subtend equal angles, so will it make any sense? So it will not make any sense. So, and the next theorem is the perpendicular drawn from the center to the chord bisects the chord. So if we draw any perpendicular, so from the chord to the center, so let me draw like this. So if I take any perpendicular from the chord onto the center, so okay, and also let me draw one perpendicular to over here. So I have drawn a perpendicular. Okay, now what is formed? So let me write this as M and this as N. So what did we do? First, in proof, in proof, draw ON perpendicular to chord AB and ON perpendicular to CD. Okay, now I have to prove that these two angles are equal. So how to prove that these two angles are equal? Now here we can prove the parts of a triangle by using the concept of congruency, right? Are you able to see two triangles here? So the first triangle is OMP. Are you able to see this a triangle? Yes. So let us see if I prove that this triangle is congruent to this triangle. Okay. So then I can prove that these two angles are also equal by CPCT, right? Let us try. So in triangle, what is the first triangle? OMP and triangle ONP. Triangle OMP and ONP. So now tell me what are the equal parts in these two triangles. So in these two triangles, what are the equal parts? Can you see 90 degrees over here in both the triangles? So angle OMP is equal to angle ONP. So it is 90 degrees which we have constructed, which we have drawn, and then is OP common for both the triangles. So not angle. So OP is equal to OP. What is the reason? Common. You have to write the reason, my dear friends. Okay. And then what else do you feel that they are equal? Are these two equal? The perpendicular drawn from the perpendiculars drawn from the chord to the center, are they equal? What is the theorem? The equal chords are equidistant from the center. This is the theorem which we have learnt. So that means OM is equal to OM. Equidistant. Sir, whenever you are finding a distance, what you are supposed to do? You have to draw perpendicular lines. So that means the distance from the chord AB to O and CD to O are equal. So therefore OM is equal to ON. OM is equal to ON. What do you write? Equal chords are equidistant from the center. This is the reason which you have to write. If you write, then you will get perfect marks. Okay. So now you have proved all three parts. Now let me see if I'll draw this diagram separately. Okay. OMP. Let me see the three parts. Angle OMP. This is 90 degrees. Then OP is this side, and OM. Here, if I take two sides and one angle, can I take this SAS? No, we cannot say SAS because side, it should be included angle and side, but it is not. So two sides and one angle. What else we can see? See, this is 90 degrees. Therefore R, and what is the side opposite to it? Hypotenuse, and this is a corresponding side. So can we use RHS congruency? Yes. So by RHS congruency criteria, triangle, what is this triangle? OMP is congruent to triangle ONP. So these two triangles are congruent. When these two triangles are congruent, what do you say about angle OPM and OPN? Are they equal? Yes sir, they are equal, because by CPCT angle OPM is equal to angle OPN. So that means, therefore, the angles subtended by the angles made by the line joining point of intersection to the center makes equal angles with the chord. You have to write the statement. Conclusion is very important. It carries half mark. So please write the conclusion. What is the conclusion? The line joining the point of intersection to the center makes equal angles with the chord. Got it? So in the next video, let us see the next question.